feels like, hey, 2025, that's the year of agents. You turn on the news, you're going to see different articles and different news coverage about the impact of AI and how it's going to transform our society. That's why we're all here talking about it. So let's actually first distinguish what's an agent. Let's say you have a standard kind of task you want to do. You need to book a business dinner with some customers. So what would you do? You might go out and open an app like OpenTable, and then you go clickety-click through, and then you find the restaurant you're looking for. But really, wouldn't it be better if you could ask the restaurant reservation app something like, I have a business dinner tonight. It's at 6 p.m. I have 5 people coming. One of them is vegetarian. And I have a meeting till 5:30. Find me an available restaurant that meets company expense policy. I think I would much rather type that prompt rather than having to navigate a GUI for the purpose of finding and booking that dinner, right? And so if we did have an agent that was a restaurant reservation agent, what would it do? First, it would have to figure out like how to find you a restaurant within 30 minutes of your of commute time to get to it, because you're going to be at the office. But how is this agent going to know where are you going to be? Where is your office located, Adib? So it has to figure out to ask me, Adib, where are you going to be at 5:30? Or maybe it has access to my calendar and it can check that. Now, presumably, restaurant reservation system has access to the restaurant's menu, so it needs to check the menu to see, hey, are there good, tasty vegetarian dishes on this menu? What's the company expense policy? Again, it doesn't know anything about my company, so it might need to ask me, is that like, and I might respond back with something like, it's $100 per person. Now, we're looking for something that's highly rated, so that it knows about. It has to have capacity, but also there's some implicit goals here. For example, you don't want to end up at a restaurant that's very noisy because you're trying to have a business conversation. So you don't want something that's too noisy. So this idea of the agent kind of taking your prompt and figuring out what are the goals that you have, those are the things that that distinguishes, in my opinion, an agent from just an application that uses AI. So let's actually take a look at what we like to call the, kind of the continuum of the different kinds of applications you can build, because I find there's a lot of like confusion sometimes out there about what it is. So if I asked any of the developers on the call today, okay, can you build me a restaurant reservation system? Everyone, I'm sure, knows how to put together a database plus an API plus a front end in order to build out a restaurant reservation application. But then you're like, hey, you know what? Maybe I'm visiting a big city like New York City. I open it up and I see there's 10,000 restaurants. Maybe we should have some machine learning. And what the machine learning model is going to do is going to make predictions about what restaurants is Adib likely to want to visit. Like what's his taste? Well, how is it going to figure out what I like? Well, it's going to do it based on my previous booking history. It might also want to have a machine learning model to predict how good of a customer is Adib. Does Adib have a habit of booking restaurants and not showing up, right? We should tell the restaurateur, the restaurant about this, so maybe they don't wait too long for him to show up, right? So these types of machine learning models have been something that our industry's been doing probably for the last 10, 15 years. And we used like data scientist teams who kind of know the linear algebra and calculus, and they know how to train a model. But they're really predictive models, machine learning models built on data that we have in the company. And that is a very different skill set that what we typical Java developers have. We're not really remembering our calculus and linear algebra. Some of us do, but most of us don't. And so the next step up in this kind of maturity model is like, hey, I just want to build a Gen AI app. Maybe what I'm doing is taking the restaurant reservation. I just want it to handle a simple task. Like the restaurant reservation app has a screen, and in the screen, I can like click a button to select the cuisine. I can click a button to select the time that I want. I can click a button for the number of people. So what if I just built a prompt that said something like this? Here's the user prompt. From this prompt model, please extract for me the type of cuisine, if you can tell it, the number of people, and the time, and the location, right? And so effectively, with this Gen AI app, you're using the model as a user interface. It's kind of like how you use a touch screen or how you use a web browser, but it's not trying to solve for a set of constraints that are implied or somewhat explicit. So that's like, but for the skill set that you need as a developer, you just need to know how to call a REST API. If you can call a REST API, you can build a Gen AI app, right? You don't need to go through this step right here where you have to remember calculus and linear algebra. You can jump straight from here all the way to here. But once you've built your first Gen AI app, it's not like, it's very exciting to say, can I make that Gen AI app like better? Can I make it autonomously solve for a set of constraints within the user's desires? So that, I hope, is giving folks a chance to understand, like, what do we mean when we talk about an agent? So keep this idea of the restaurant reservation agent as we go along, okay? So when we talk about these agentic systems, we're really talking about using the AI models to interact with the environment. Okay, so for example, the restaurant reservation agent, I told it that I'm going to be at the office till 5:30. So how does it know where my office is? Or now if I tell it, it knows where the restaurant is at. It needs to figure out, well, how long is it going to take Adib to get from his office to the restaurant? So it needs to perform actions in the real world, like, for example, maybe it should book me an Uber or something like that, right? And so this is where there's two stages to building these agents. There's a stage where, it's a planning stage, where the agent is going to handle reasoning to kind of come up with a plan and what actions to take. But then there's the actual action that you need to take, which are the tools. And that idea of using the model to come up with a plan and then using tools to execute the plan is kind of central to this whole thing. And those two things, where you have they come together in what's called the agentic loop. So I don't know if anybody's already covered this in the conference so far, but if you've seen it, well, this is a review, right? So this idea of we go to the model from our agent, we ask the model to come up with a plan with a set of constraints, and then that's the reasoning planning step. And then we go through and then we perform some operations, and we might need to go through this multiple times to get the result we want. Perhaps the agent is going to say, Adib, I found 4 possible restaurants. Which one do you like, right? So there's an element of memory and kind of remembering what has happened along the way in the interaction that you also have to solve for. And so if you're new to AI, or you haven't had time to look under the covers to understand, like, what is this thing called tool calling? So let's actually quickly review this with some nice diagrams. Let's say I go here and I say, what to wear today in Amsterdam, okay? And the prompt that's going out doesn't just have this part up here where I'm hovering my mouse. That's actually what the user typed. There's also a tool description. And you can see here this green area says, I have a tool called Get Weather. It has a description, and it has an input of city name. Okay, so that's going to go to the model, and the model is trained by Azure and others to basically be able to figure out that in order to answer the prompt, the question the user asked, it might need the information from this tool. So what's going to happen is the response that's going to come back is going to say, the model is going to tell to the application, okay, you told me you've got this get weather tool. Can you please invoke the get weather tool and pass for the city called Amsterdam? So the model is deciding two things: what tool to use, number one; number two, what the arguments to that tool should be. And that is what's kind of happening in this scenario. And so now what happens is that the application is going to first take the tool response. Okay, it's 12 degrees and it's raining. And it's going to send the old history, so the whole entire previous interaction, because the models themselves are stateless. They don't remember anything. You have to kind of give them the whole entire context every time you invoke them. And so you can see now we have the previous what should I wear today from the user, plus here are the tools that are available. We have the response from the assistant saying, please call this tool, and this is the parameters, and we have this new user input. And then from that, the AI is going to come back and say, okay, you should wear a jacket and get an umbrella. Now, I hope this gives you a sense of what these tools do. These tools are things that you write yourself. This is code that you write, but it's code that allows you to adapt, to on-demand offer the model data that is not part of its training set. So let's talk about, see what this can look like. This pattern, this tool is like the foundational thing you need to build agents. And so that's why I'm covering it in a little bit more depth to explain to you what's happening under the cover. The model does not call your database. The model does not call your API. The model will ask your application talking to it to access the database, will ask your application to access the API. So how are we going to turn this into real world stuff? Well, we're going to use Spring AI. Okay, what is Spring AI? It's an application framework. It's portable AI service abstractions. It's really all about developer productivity. And we have a very simple code goal. We want you to be able to keep up with all the latest developments in the AI world. So let's quickly take a look about how you would code that tool that I showed you earlier. So if you look at this one here, you'll notice that you've got a pretty simple looking piece of code like get weather. And what's different about it is if you've used Spring before, you may have written something like at rest controller with at request body and all this type of stuff. We have a bunch of annotations that allow you to describe to Spring AI what this adapter code is doing. So in this case, we're saying, well, this particular function called get temperature, it's a tool. And this tool has a description, get the temperature in Celsius for a specific location. And then we can specify that there's a tool parameter with the inputs that are needed, the longitude, the latitude, and the name of the city. So we're asking for 3 inputs. And then what we're doing inside is what you would expect. We're calling out to an API that takes a longitude and latitude and retrieves the weather report at that location. And then what we're doing is we're returning that weather response. So now what happens is that you've got this tool, it's sitting there in your application. And the question is, I'm going to make a request to an AI model. How am I going to do that? Well, there's this concept called a chat client that's built into Spring AI. So you can see here, I simply say, I've got a chat client.prompt, and I give it a tool. And what tool am I giving it? Well, I'm giving it a list of tools, including the weather tool here, which we're saying ... because you had done like new weather tool or gotten the bean or something like that. And then we can put our user request, what to wear today in 2 different cities. We make a call and we get the response. And that's really all you need to do to get this. So this goes back to my earlier statement. You don't need to remember calculus or linear algebra, or you don't need to know Python. You just need to know how to call a REST API. You need to know how to describe code. And there's a very idiomatic Java way of doing that. And that Java way of doing it is really what we're after in exposing it to you in the Spring AI framework. And also not just in a Java idiomatic way, but also in a very Spring idiomatic way. So it's consistent with the rest of Spring portfolio, right? Now, there are 2 types of these agentic systems that one can build. One is kind of like workflow-based agents. And these are where you have LLMs and tools that are orchestrated through predefined paths, right? And those are, for example, let's say you're trying to offer a product recommendation, or like that restaurant reservation example. So there may be like a workflow that should happen. Like I should check for location, if it's relevant, the travel time. I should check for allergies. I should check for various other things like noise level. So whatever are the parameters that normally people would need to check for, you might pre-program them in as things to see if they're relevant for that prompt. And that would be more of a workflow-based approach. The other one is an autonomous-based approach, whereby you're basically letting the agent kind of completely come up with a plan 100% on its own, and then execute that plan in whatever way, shape, or form it wants. Now, no surprise here, if you think about it, the workflow-based approach is not going to require as much capability from the AI model itself. Like if you want to do the 100% autonomous agents, you really need an AI model that is really, really powerful. And so at this point, I think I'll just take what Anthropic is saying in their Building Effective Agents blog post from December of 2024, just a few months ago, where they're basically pointing out that what they're seeing work in the real world right now are composable patterns rather than complex frameworks, and more of the workflow-based approaches. Uh, you know, the reason why is that the workflow-based agents are a little bit more predictable and consistent for well-defined tasks. At this moment where we are in the industry, let's be honest about it. Most applications don't have AI capabilities in them. Sure, we're lucky, we're developers. We are spoiled for choice. We can choose to use GitHub Copilot, we can choose to use Cursor, we can choose to use Windsurf, we can choose to use Claude, we can choose to use like one of an infinite amount of tools out there for like assisting us as developers. But let's say you're a sales team working for a company, and you have a meeting coming up with an important client, and you want to find out like what is the maximum discount I should be able to offer this important client. And you may want to look at factors like, what inventory do you have that hasn't sold yet, and what is the purchasing history of this client, and various other things. So if you were to think about it, wouldn't it be great if you could build like a sales co-pilot for your sales team, so they could use it? Now that sales co-pilot needs to be integrated into the application that your sales team is using, right? And that means that you, as a developer of that sales application, need to be able to go in and enhance it. And so I think the opportunity to build these workflow-based agents today is a lot bigger than the opportunity to build the fully autonomous agents. And I would encourage all of you to start there, because it's just, you're going to get better results. So what are some of these things that you can build? So right here is a screenshot from a set of diagrams from a bunch of the patterns that were put together and published in that really nice article from Anthropic. We also published, Christian Solaf from the Spring team also published an article showing how to implement all those patterns with Spring AI. You can see the links on here to do this. So you'll see things like, for example, chain workflow, which basically means I'm going to break down I'm going to take the input, and I'm going to figure out what are the steps that need to happen, and I'm going to execute those in order. You could have a routing workflow where you can look at the prompt. You're like, what kind of issue is this? Oh, this is a customer that wants to return their product. This is a request to troubleshoot something. This is a request for a discount. So you know where to route the request. You may want to have something where you're running these tasks in parallel and then you aggregate them, right? That's down here. You might want to do something where first you orchestrate and you figure out what are the steps that need to happen, and then you bring together all the answers. Or you might have like this evaluator optimizer where you have the LLM generate a solution, and then you have another LLM that basically says, okay, let me see if you did a good job or what's wrong with it, and you kind of go through this loop a few times. So what I want to do next is kind of like jump to the code and show you how you could implement one of these. So I'm going to go here to my IDE. I hope everybody can see the IDE. I assume you can. Speak up if you can. And the code here, first of all, let's actually see where this is from. So if we look at this is from the GitHub Spring project, Spring AI examples. We have a I don't know why my browser isn't coming up, but oh, there it is. Okay, this is a place where you can find lots and lots of examples about these, including this agentic patterns here, which is what I'm one part of the repo that I'm focused on. You can see the rest of the examples in here. So let's go back to IntelliJ. And within this, there is an application here, and I'm going to focus on the orchestrator worker. So I've got some breakpoints set up. So let's just take this and debug it. All right. And then here is you can see, first of all, this isn't like some giant piece of code. There is like, I don't know, 200 lines of Java code really outside of the main method. And it's Java, it's wordy, it's verbose. So this is not very complicated. So let's go back here to where we're at. So we're going to start by creating an orchestrator workers, and then you're looking at this and you're like, hey, is that a class from Spring? No, it's not. This is just how easy it is. Like a lot of the time when you're building these, you don't need to reinvent the wheel. You've already got a mature ecosystem of things, and you're a developer. You can write code, right? So what we're doing here is we're just representing that pattern in a class called orchestrator workers. And so we're asking it to write a product description for a new eco-friendly water bottle. So let's see what happens if we continue on. So what are we giving it? Well, we're giving it a chat client. Chat client is the central interface in Spring AI that you use for interacting with any type of AI model, whether it's a chat model or other things. And so we're taking an orchestrator prompt. So let's actually just get through these lines of code here and look at that. So the orchestrator prompt is basically saying, analyze the task and break it down into 2 or 3 distinct approaches. So let's actually see it up here. It's you can see it a little bit more easier to read. So we're giving it a task that's being passed in. So you'll notice here, I've got this like curly brace thing. Please substitute the task in this one. And then we're asking it to return a response like, here's my analysis, and here's the tasks needed for that. Okay, so we're looking for write a precise technical version that emphasizes specifications, write an engaging, friendly version, and on and on and on. So that's to give it an example. So we'll go back here, and let's step over this. Oops. Okay, so now we're calling the process. So our task description now is write a description for the eco-friendly bottle. So our step 1 is we need the orchestrator to take this, to take the orchestrator prompt, which is telling it to kind of come up with some tasks based on this plan for how to do the analysis. And then what we're doing is we're passing our task description, we're calling the model, and we're going to get a response. And let's actually see what kind of plan it has decided to. Oh, we're waiting for it to come back. All right. So let's step over that and step over. Okay, so let's take a look at our console. Okay, so you can see here product description for an eco-friendly water bottle. Requires balancing technical specification with emotional appeal. The key aspect includes sustainability features, practical benefits, environmental impact. Different approaches can target different consumer motivations, blah, 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 blah. Okay, so that's one thing that it came back, but it also came back with a list of tasks. So you can see here there's a technical environmental task where it's creating a specification-focused description for highlighting the materials, manufacturing process, recycling, blah, blah, blah. There's another task which is lifestyle-focused, where it's trying to kind of develop a nice description emphasizing how the bottle fits into the eco-friendly lifestyle. So we've got 2 tasks in this example, right? So now what we're going to do is we need to take each of those tasks and we need to send them to the model. Well, how do we do this? Do we need anything super specialized? No, we don't. We have a list. And if you have a list in Java, you can just say list.stream.map, and I'm going to give it the task. And I'm going to say, okay, I've got a chat client. So let me create a prompt based on the original task, the task type, and the description. That's what I'm going to send to the AI, and it's going to come back with a string response. So let's actually kind of continue with this. Okay, so we'll wait for it to execute and come back. Oh, and what do we have here? What did I do? I think I pressed it too many times. Or maybe I timed out because I was talking. So let us... Oh, we're waiting on something? Okay. All right, so...
Yeah, Dave, we are, just so I know, we are at time.
We're at time. Oh my God. Okay, I got one final slide. Is that okay? All right. So I just wanted to basically, now that I showed you this, I just wanted to wrap it up. Just say, look, there's 2 approaches to build one of these agentic frameworks. There's a bottom-up approach, which is what we've taken with Spring AI, where we wanted to build the foundational foundational abstractions first for how to do portable model access, capture reusable AI logic, observability, vector stores, and then allow you to implement these AI patterns on top of those foundational patterns. And our goal is to offer first-class foundational and agent abstractions. There's another way you can build an agent framework, which is to just build it top-down. You build the high-level agent framework first, and then you figure out how to make that agent framework work with all the different model providers, and then you iterate on the abstractions. So the goal of this one is to just let you build agents, whereas the goal of the bottom-up approach is to give you multiple levels of abstraction. So thank you. That's what I wanted to share with you today.
Awesome. Thank you so much, Adib. This was a great presentation, and I'm sure that developers have now a much better sense of building agents with Spring AI. But not only that, you gave lots of interesting thought process on how to think about building agents and when and where and how they are usable in applications, especially enterprise applications. Stay on stage quickly, and I'd like to welcome Reza to join us. Hello, Reza, and also Emily. Hi.
Hello.
Welcome. So, I'm not sure if you were following Adib because we were on the backstage, probably preparing for your presentation. But what do you think about AI agents doing stuff for us?
It's early days for it. I mean, it's a long time coming for those of us who have had an academic interest in AI. We were thinking about dreaming up such things, almost 15 years ago. So it's good to see it finally come to fruition. I think it's still early days. We'll see what the practical applications are and to what extent it actually adds value to the end user.
Thank you, Reza. Emily, what are your thoughts?
I really think agentic AI is kind of going to be the hot topic. It already is in basically 2025. And I will see basically it's I'm already imagining when I wake up, my AI agents tell me doing all the stuff for me and create a action item for me. So this is the kind of for us, and also for the applications. I think is for the chatbot. And AI agent is going to play an essential role there. I really think that in the future, a lot of applications will be agentic AI applications.
So, as the three of you are conference speakers. You travel, you present. Emily, I'll ask you: what is the one agent that you like Adib to build that would help your life as a conference speaker?
Yeah, I tell you what it will be. Plan my kind of the trips and how to get to my hotel room, and which train to take, which public transport, or if not, basically, and then what time to get up and to go to the also can build up my conference days as well. Like I also need to attend some of the, even though I travel at a conference, I probably most of you are as well, also need to do some calls as well, right? I want an AI agent to tell me actually, yeah, this call you must attend, you must do. And then it's kind of also plan some interesting talks, and then arrange some meetings to meet some other friends and also the experts. And I really love the basically meeting people at the conferences, and then broaden my horizon a lot. I think that's where I got a lot of wisdom from.
Adib, is that something you can do vibe coding for an hour?
No, but I can tell you that the one agent I built for speakers, it takes your LinkedIn and makes a bio for you. Because I hate writing bios for myself.
All right.
That's one of my Git demo repos. But that one is more than an hour of coding. I may need an AI agent to help me build the new AI agent.
Absolutely. All right, Adib, thank you so much again. Have a wonderful day.
Bye-bye.
And Emily and Reza, yeah, thanks for joining JDConf, and you're welcome to start your presentation now. Thank you.